Hello guys, I welcome you to NEET World. So in continuation to the last discussion that we have discussed the previous year questions of GOC for NEET and EAPCET 2025, right? Okay, so now in that live session we have discussed almost some 20 to 25 questions, and finally I have provided few questions as a homework. So those which I am going to discuss here in this session. Okay, so those who are directly came to watch this video, so you can access those video and you can also watch the questions which we have discussed in that video also. Okay, so that will be highly helpful. So let us discuss what are the homework questions which are given in the last session. So here this question I have given as a homework. So for the following radicals, correct order of their stability. Yes, so 4 radicals are given here, so identify their stability order. Yes, so we know stability of carbocation, stability of free radicals is explained by hyperconjugation as well as mesomeric effect and inductive effect. So these are the 3 effects. Now identify what are the effects possible in the given options. So in all these options there is no scope for mesomeric effect because there is no conjugative position with the given radicals. So all the radicals are like not having the conjugative position with respect to the pi electrons. Yes, therefore there is no mesomeric effect. Now we can discuss about hyperconjugation and inductive effect. Yeah, so since free radicals are electron deficient, like it is having only 7 electrons, now electron releasing groups, those groups which releases electrons towards that free radical carbon, that will increases the stability of like that free radical carbon. So electron releasing groups increases the stability of free radicals. Now look here, so this carbon, this radical here is tertiary carbon radical, right? This is attached with the 3 carbons like this, 3 sides, right? Here it is alkyl group, here also 2 hydrogens are there, so here 1 hydrogen. Again this is having 1 alpha hydrogen. So like this, first of all identify, now we are discussing about hyperconjugation, how it is stabilizing. Now identify how many alpha hydrogens are there for the each of this radical. More the number of alpha hydrogens, more is the resonating structures, more will be its stability. So here for this we have 2 hydrogens here and 1 over here. Here 2 alpha hydrogens here and 1 alpha hydrogens here. So number of alpha hydrogens give that many number of hyperconjugative forms. So for this 3 plus 3, 6 alpha hydrogens are there, 6 hyperconjugations are possible. For this only 1 hyperconjugation is possible as it is having only 1 alpha hydrogen. For this 3 alpha hydrogens, so 3 hyperconjugations are possible. For this it is also having 3 hyperconjugations are possible, 3 alpha hydrogens. So out of this we got to know more the number of hyperconjugation, more is the stability, therefore A will be highly stable. Yes, fix this. Next, out of these the least number of hyperconjugations taking place in this case, right? So and this is primary radical, so this will be least stable, so B will be least stable. I hope it is clear how we are fixing least and most stable. Yeah, so now identify options from this, so it is better like elimination method also we can use. So A is more stable, A is more stable here. Yeah, only one option is there, directly we can go through the answers, directly we can choose option C. So if you want I can also explain why C and D are having intermediate stability and which is more stable here. So here for this we have 3 alpha hydrogens, here also 3 alpha hydrogen. Now we cannot conclude the final answer out of this C and D which is more stable by hyperconjugation. Now go for inductive effect. Okay, now this carbon free radical is tertiary, right? Because it is attached to the 3 carbons directly. What about this carbon radical? So this is secondary radical, right? So which is more stable, carbocation? Tertiary carbocations are more stable because inductive effect is more for tertiary carbon. This 3 sides plus I effect will be there, so 3 plus I effects are there here, but here it is only 2 sides from here and from here, 2 plus I effects are there here. So which is having more plus I effect, that will be more stabilizing. So D is more stable than C. So A, D, C, B. So A, D, C, B. I hope it is clear. So no confusion, nothing. right? Let's move forward. Yeah. Which of the following lacks hyperconjugative stability? So how can we identify hyperconjugation? In order to show hyperconjugation, what is the minimum criteria? There should be at least one alpha hydrogen attached to that stabilizing system. I mean, if carbocation has to be stabilized, there should be at least one alpha hydrogen attached to that. See, the carbon attached to it can be called as directly carbon attached. See, this carbon, these 3 carbons which are directly attached are called alpha carbons, and hydrogen present on that carbon will be alpha hydrogens. Therefore, here 6 is 3, 3, 3. So 9 alpha hydrogens are there, 9 hyperconjugations are possible for this. Okay. For this, here we can see 3 alpha hydrogens are there, alpha carbon is there, so therefore 3 alpha hydrogens, so 3 hyperconjugations are possible. And what about this? So here for this, these 2 carbons are alpha to this carbocation, so therefore 6 alpha hydrogens, 6 hyperconjugations are possible. And see, A, B, C, all these 3 are having alpha hydrogens, therefore hyperconjugation will be possibility for stabilizing the carbocation. But in D, there is just carbon with 3 methyl groups. There is no stabilizing factor for this particular carbon with like there is no hyperconjugation, because at least there should be one carbon attached to it, and that we should have at least one hydrogen, that is what the alpha hydrogen, right? If there is no alpha hydrogen, no hyperconjugation. Therefore, D will be not having hyperconjugation, or I can say lacks in hyperconjugative stability. So D, which is here, this is the correct answer. I hope it is clear. Now tell me, for the following compounds, the one which contains both sp2 sp hybridized carbon, very easy, just count number of sigma bonds around the each of this carbon, that will gives you the hybridization. Okay, these are generally like most frequently asked questions in EAPCET. Okay, see here, this carbon and nitrogen, between carbon nitrogen we have 3 bonds here. So one you can consider sigma and 2 pi bonds, and this side we know carbon have tetravalence, it can form 4 bonds now. So 3 bonds over, the 4th bond is here. So here 1 sigma and here 1 sigma. Okay, like that. So here 2 hydrogens, it means 2 sigma above and below, and with respect to this carbon again 1 more sigma. So this carbon is sp, and this carbon is sp3, and this carbon is, see, for this carbon it is like this, C double bond O OH. It means 1 sigma, 2nd sigma and 3rd sigma and 1 pi. So consider only number of sigma bonds around this carbon atom, that gives the hybridization number. Like see here 3 sigma bonds, I can say sp1 p2, I mean sp2, like 3 hybrid orbitals now, one is s, remaining 2 are p, so I can say sp2. I hope it is clear. Okay, they are asking which one contains both sp and sp2 hybridized. Yes, so one contains sp and sp2. Yeah, there is multiple selective question it is. So now what about this? So 3 pi bonds are there. So for this carbon, one, see this you should write hydrogen, carbon, triple bond, carbon, single bond, triple bond, hydrogen. So this is sigma, so I can say this is sp hybridized. Again here 1 sigma, this is also sp hybridized. Now here 1 sigma, this is also sp hybridized, this is also sp hybridized. All of them are sp hybridized, but we require both sp2 and sp. So this is not the suitable one. Go for the next option. So this will be, I already explained in the previous video, this will be having sp2, and this will be having sp, and this will be having sp2. Yeah, so we can tick this 3rd option also. And the next 4th one here, all these carbons in this phenyl ring are sp2 hybridized, and this carboxylic acid group which I have explained here also sp2. Okay, so this is having only sp2, so this is not the suitable one. Okay, only we got 1 and 3 till now, and next these all are sp2 hybridized as we discussed here only. And this is what, triple bond is there, means 1 sigma and 1 pi, like 2 pi bonds now. So 1 sigma here, 1 sigma here, therefore this is sp. Hope this is also clear. 2 sigma bonds, so sp, like that. Okay, so it contains sp2 and sp. Yeah, so I can say answer 1, 3, 3 and 5, and what about this? So all these are sp2, and this carbon is also sp2 as it is having 3 sigma bonds. Hope it is clear. So all of them are sp2, so this is also not the exact one. So 1, 3, 5. So option D is suitable answer for this particular question. I hope there is no confusion in this. Next, decreasing order of stability of given carbocations. So how can we identify the stability of carbocations? So in order to answer this question, so apply all 3 effects: mesomeric, hyperconjugation and inductive. Okay, so here first, is there any possibility for mesomeric effect? No, because there is no conjugative positions. I mean, there is no pi electrons or no non-bonding electrons to stabilize this carbocation, right? Okay, now we have to check for hyperconjugation and inductive. So first look for the hyperconjugation. So in order to show hyperconjugation, it requires at least 1 alpha hydrogen. Look for this carbocation. Here we have 1 alpha hydrogen. This is the carbon is alpha carbon, hydrogen is alpha hydrogen. So 1 hyperconjugation takes place, okay, and complete group you consider as 1 alkyl group and 1 plus I group is there. Inductive effect will be there. I hope it is clear. These are the 2 effects possible in A. Now go for option 2. I mean option B. Here you can check. This carbocation having alpha carbon here, here, here. So 3 alpha carbons. So on each one, here it is 3 alpha hydrogens, here 2, here 2. So totally 7 alpha hydrogens are there. 7 hyperconjugations are possible to stabilize this carbocation. That is also clear, I think. More the number of alpha hydrogens, more the number of possible hyperconjugation, more is the stability. Therefore it is more stable than the previous one. So B is more stable than the B is more stable than A. Now go for the next one. Again, now what about inductive effect? This is 1 alkyl group, 2nd alkyl group, 3rd alkyl group. So I can say 7 hyperconjugations and 3 plus I groups. Up to here it is clear. Now to this, check, this is 1 alpha hydrogen, 2 alpha hydrogens, here 1 more. So 3 hyperconjugations are possible. Again, this is 1 alkyl group, 2nd alkyl group. So I can say 2 plus I groups. Okay. Next, what about this? Here we have 1, 2, 3, 4. 4 alpha hydrogens, 4 hyperconjugations are possible. And the next, this is 1 alkyl group, this is another alkyl group. So 2 plus I groups are there. So now out of these, now conclude which is stabilizing more here. 7 alpha hydrogens, 3 plus I group, therefore this will be more stable. B will be more stable. Yes, so B is more stable in option C and option D is there. Yeah, so eliminate A and B. First 2 you can remove, this you can cross. Yeah, then next, which is the least stable? Here only 1 alpha hydrogen is there, therefore A is least stable. Yeah, it is there in both cases. Yeah. Now out of C, D, how can we identify 3 alpha hydrogens, 2 plus I groups, both case it's fine. Here it is having only 3 hyperconjugative forms, but here it is 4. Therefore D wins here. So D, C. I hope it is clear. So B, D, C, A. So you can choose option C. Right? Next, identify the chiral molecule among the following. See, chiral molecule, if you want to check, there should be carbon surrounded with 4 different groups. Yeah, so like A, B, C, D, like this, 4 different groups. Okay, so now write all the structure, like write the structures of these given molecules and identify. So for example, if I write 2-pentanol, so how can I write butane, pentane, 2-pentanol, like this only na? 1, 2, 3, 4, 5. So 2-pentanol. Okay. So now to this, identify is there any chiral carbon is there or not? See here, this carbon, this side is 1 alkyl group, this is completely 1 alkyl group. I told you na, 4 different groups like A, B, C, D should be there. So this completely 1 alkyl group, yeah, 1 group, and this is 1 methyl group, yeah, something like A, B group, and this is OH, which is completely different from the remaining two, okay, and one more is hydrogen. So 4 groups are different now, like A, B, C, D. Yeah. So when there are 4 different groups on a particular carbon atom, so that carbon can be considered as chiral carbon, chiral center or chiral carbon. So option B will be correct only. So you can cross check for the remaining options also, okay, and tell me if there is any other chiral center in any of these compounds, okay, fine. Next, correct order of stability of the following compounds based on hyperconjugations is, yeah. So hyperconjugation stabilizes. What are the applications we discussed? There is a special video on hyperconjugation, you can watch that if you haven't watched it yet, okay. So that will be very helpful and you will be getting some clear idea on hyperconjugation and its application, okay. So correct order of stability of following compounds based on the hyperconjugation they are asking, yeah. So applications, what are the application? Hyperconjugation stabilizes the, increases the stability of, or it explains the stability of carbocations, free radicals, right? Carbocations, free radicals I am saying, okay, and alkyl benzenes I told you, and the next I told you stability of alkenes. What I told you? Alkyl hyperconjugations explain the stability of alkenes. Now these 4 options, given 4 options are alkenes only. Now to this double bond, alkene means it should be like this now. It will be like this, okay. To this carbon centers, how many alkyl groups, how many alpha hydrogens are present? How many alpha hydrogen? For example, here we have a carbon now. So this carbon is called alpha carbon with respect to this carbon, which is double bonded carbon, and if this is alpha carbon, hydrogens are alpha hydrogens. Now this kind of hydrogens, more the number of alpha hydrogens, more is the stability of this particular alkene. That's it. Now look here, the one which is having more number of alpha hydrogen, that will be more stable alkene. Yes, I hope from this statement everything is clear here. Look here in option 4, we will directly go to option 4. So here this is the carbon double bond, alkene center. To this is alpha carbon, this is also alpha carbon, and these two are also alpha carbons. So totally how many alpha hydrogens are there? So this side 2 alpha hydrogens here, 2 here, 4, here 3, here 3. Total 10 alpha hydrogens are there for these alkene carbons. Therefore, that will be stabilized by 10 hyperconjugative forms or 10 resonating hyperconjugation structures will be possible. So I can write 10 hyperconjugations or hyperconjugative forms are possible for this, okay. Similarly, come for this now. Here to this, here 3 is alpha carbon, hydrogens are alpha hydrogen, therefore 3, 4, 5, 6, 7. So 7 hyperconjugations are possible here, okay. What about this? So here 4 alpha hydrogens are there, 4 hyperconjugations are possible. I hope it is also clear. Next, what about this? So here there is no alpha hydrogen this side, so no hyperconjugation this side. See, directly attached hydrogens, see here it is directly attached. So this is not the alpha hydrogen. What I am saying, to the alkenes there should be directly connected carbon, that carbon is called alpha carbon, and hydrogens present on that will be alpha hydrogens. I hope it is clear. So this carbon is alpha carbon, hydrogens are alpha hydrogens. The directly attached hydrogens are there now, those are not alpha hydrogens, they won't stabilize the alkenes. Only alpha hydrogens will stabilize the alkenes. I hope it is clear. That is what a hyperconjugation explains, okay. So you can watch for more clarity, you can watch that video from the playlist, okay. So this is no hyperconjugation possibility there for here because no alpha hydrogen. Here we have one alpha hydrogens, so it can be stabilized one time by this alpha hydrogen. So now tell me which is more stabilized here. So 4 is more stable alkene, the next 3, the next 2, least is 1. So 4, 3, 2, 1. Yeah, option 1 is correct for this particular question. I hope it is clear. If there is any doubt or any confusion, just ask me here. Okay. And whatever we discussed this thing in the last video only, I told everything about the carbocation rearrangement and all. So you can watch that video from the playlist. Okay. Now tell me the correct order of the relative stability of the following carbon anions. Yeah. So which carbon anion is more stable? Yeah. First of all, you need to check for the resonating structures or any mesomeric effect is there. Yes. This carbon anion is more stable because C6H5 means phenyl ring. So like this, we have 2 times. So it will be stabilized by 2 phenyl rings. Therefore, I can say 4 is more stable. And see, here also we have allylic carbon anion. So this will also be stabilized by resonance. Therefore, I am writing 4. After 4, I am writing 2 here. After 4, I am writing 2 because of resonance stabilization. After this, see, alkynes are more electronegative than this alkene, right? Therefore, alkyne, like more electronegative carbon hold the negative charge more effectively, and that will stabilize the negative charge more effectively than this double bonded sp2 carbons, I can say. Okay. So 4, 2, 1, 3. So option C will be correct for this particular question. I hope it is clear. Next, identify the correct statement from the following. Electromeric effect is a temporary effect, not permanent effect. So this is incorrect. Next, hyperconjugation is a temporary effect. No, hyperconjugation is a permanent effect. This is also incorrect. See, inductive, mesomeric, hyperconjugation. These are permanent effects. Permanent effect, and electromeric effect is temporary effect. You can remember these statements. Now, fractional distillation is used to separate 2 liquids from a mixture if the difference in their boiling point is less. Yeah. So when it is having very less difference, okay. So we can use fractional distillation to separate them. Okay. The boiling point of 2 liquids are very close. Okay. Or very less difference is there. Then we can use this technique to separate them. Next, yes, this is correct only. Different compounds are absorbed on absorbent on different extent. Okay. So when we are doing chromatography, like thin layer chromatography or column chromatography, so there we will be using like adsorbent, like silica gel or something like that, or alumina we will be using. So on that, the compounds depending upon their retention factors, we can say their absorption capacity. So that they will be having different extent of absorption. So they absorb different extent, we can say. So that is what we will calculate using retention factor. So RF we will be saying distance travelled by component by the total distance travelled by the solvent front. We will be calculating like that. So D3 and 4 will be correct because this retention factor will be different for different components depending upon their ability to absorb on that particular absorbent. Yeah. So I can say 3, 4 are correct. So 3, 4, option D is there. Next, I explained this in the previous class only. NEET 2016 question. Yeah. So out of this, which is coplanar, like all the atoms should be one plane. So all atoms are coplanar. Yeah, in one plane they should be. Okay. So here this nitrile group, like see, if there is sp hybridized, like linear if it is, all the atoms will be in one plane. But here these are okay, up to here it is same plane, but alkyl group, see this is methyl. So for carbon, this methyl group carbon, it will be sp3 hybridization. So it will be having tetrahedral structure. So the 2 hydrogen atoms will be different plane when we compare with this plane of these other elements or other groups. Therefore I can say this is non-planar. And see, all these are sp3 hybridized carbons on this compound, in this compound. So they will be in different planes, that hydrogen atoms will be in different planes. So I can say this is also non-planar. Okay, not in one plane, or I can say not coplanar, I can say. Here also same story applicable. Here hydrogens are having, like these carbons are having sp3 hybridization, so they will also lies in different plane for this cyclohexane. So cyclohexane structure you can also take from this chair and boat forms like this. Okay. Next, this is also not planar. Okay, not in, I can say not coplanar. Okay. What about this? All carbons are sp2 hybridized. Here also all are sp2 hybridized. okay, and there is no bulky groups here. So it means this one will be lies in same plane like this, okay, with sigma bond like my thumb, okay. So now all the atoms here and here will be lies in same plane, therefore I can say it is a coplanar. So in the following molecule all atoms are coplanar in first option. I hope it is clear. Now here for this we can say diphenyl or biphenyl here. So this is coplanar, this is the answer you have to choose for this particular question. I want to extend my explanation little more. If any bulky groups are there here, like this. So now due to the repulsions between these bulky groups, any bulky groups I am saying like sulfonic acid group or methyl groups here also some nitro group, and here some bulky group I can say some something like NO2 group or anything. So due to these bulky groups there will be electronic repulsions now between this group and this group, steric like repulsions will be there, okay. So due to that one group and other one, that like this phenyl group and this phenyl ring will be in different plane in order to avoid that electronic repulsions or steric repulsions between these bulky groups. I hope it is clear. Then it will become non-planar or not coplanar, I can say. I hope it is clear. If there is no groups, the molecule will be in same plane, okay. So for this particular question this will be the answer as of now. Yeah. Next, consider following compounds hyperconjugation occurs in. So tell me, hyperconjugation occurs in which of these? Yeah. Look to this. What is the minimum criteria again? At least one CH, alpha CH sigma bond, alpha hydrogen should be there. At least one alpha hydrogen should be there, or alpha CH sigma bond should be there in order to show hyperconjugation. To this radical, look here, the attached is alpha carbon is there, but there is no alpha hydrogen. There we have only alpha methyl groups. With alpha methyl group there is no hyperconjugation. If there is alpha hydrogen like this, one hydrogen is there, that will participate in hyperconjugation, but not methyl group. Therefore there is no hyperconjugation in this first compound. I hope it is clear, okay. Now apply the same concept over here. To this, is there any alpha carbon having alpha hydrogen? Yeah, just write radical Yeah, like this we can write. I mean 3 sides pH means 3 phenyl rings, you have to write like this. So to this is the alpha carbon. Is there any alpha hydrogen on that carbon? No, because this carbon having 3 sigma bonds like this and 1 pi bond, partial double bond character will be there now in the phenyl ring. Like this if we write, see 3 sigma bonds are there and 1 pi bond is there. There is no hydrogen attached to this carbon, there is no alpha hydrogen to participate in hyperconjugation. So this compound will not be having any hyperconjugation, this one also. And for this you can see this is alpha carbon, this is a carbon free radical. To this we have adjacent carbon which is alpha carbon, and here we have 1 hydrogen that can be called as alpha hydrogens. Now hyperconjugation is possible like this. CH3 like this. I mean, see, when we are writing alpha hydrogen, like when we are writing stabilization for free radical, how many electrons are required in order to make a bond? Already 1 electron is there, na? So indicate with a single head arrow, I mean movement of only 1 electron. So it will be giving like this, forming a bond, and 1 hydrogen will stays like this. So this is what the hyperconjugative form of this third structure. Okay, so hyperconjugation only possible in this third option, not in 1 and 2. So only 3. So option 1 is there, which is suitable for this particular question. This is also NEET like 2015 question. Next, hybridization of each of the carbon in the following compounds. Yes, so this is what 3 hydrogens, 1 carbon-carbon bond, means 4 sigma bonds are there, sp3. Hope it is clear. Next, to this carbon 2 sigma bonds and 1 sigma 1 pi, 1 sigma 1 pi. So 3 sigma bonds totally to this carbon, so sp2, and for this it will be 1 sigma, second sigma, 2 alpha, 2 hydrogens means 2 more sigma bonds. So totally 4 bonds are there around the carbon, 4 sigma bonds, so 4 means sp3. For this cyanide means we should write like this, okay, 3 sigma like 1 sigma, second sigma and remaining are pi, therefore only 2 sigma bonds, so 2 hybridization number 2 means it is sp. So choose the option which is having like this sp3, sp2, sp3, sp. Yes, first option is correct for this. Hope it is clear. The 2 NO in like, yeah, so nitromethane is given like this, like this. So what they are saying, the bond length of N and O, I mean this NO and this one. So I can write for more clarity, we can write this like a coordinate bond or like normal covalent bond like this. Yeah. So what they are saying, so if I say the bond length is NO bond length is X here, and if it is Y, they are saying that X and Y bond lengths of this one and this one are equal. X equals to Y they are saying. Why it is same, they are asking us. Are same bond length, NO and N single bond O in this compound are same bond length due to which effect? See, this is nothing but the conjugation of this negative charge with this pi bond now. So which will give us, write the methyl group as it is, and here nitrogen is there, yeah. So when it is participating in the conjugation, these pi electrons are moving, so I can write it single bond becoming pi bond, I mean NO, and this pi bond becoming sigma bond by shifting of that pi electrons as a negative charge. So see, so this kind of conjugation we can say equivalent conjugation when the atoms are same here. So this, due to equivalent conjugation, both resonance structures contribution will be equal amount, and therefore the resulting compound the bond length X and Y bond length will be, XY length will be same like this. So what is the effect I told you, like mesomeric effect or resonance effect. The pi electron and negative charge conjugation is taking place now, so we can say resonance effect. If any alpha hydrogens involved, hyperconjugations we need to say. I hope it is clear. Why it is D? Because of conjugation of pi bond with the negative charge, which is equivalent conjugation. Now, yeah, so this is important whether you are preparing for NEET, JEE or EAPCET. Look here, the correct stability of the following alkoxides. Okay, now write this nitro group in this format first, N O minus N plus, like this if we write. Look here, this is a pi bond here. Okay, see here the conjugation, the negative charge will delocalize here and this will become a negative charge on this carbon, right? Okay, write the structure. Like this. Okay, now this negative charge is continuously conjugation with this nitrogen double bonded oxygen, and we will be having a one more resonating structure like this. So this is the resonating structure we will be getting from this particular one, right? Okay, so we can say continuously negative charge in conjugation with this pi bonded oxygen, right? But when we go for this, the negative charge can conjugate like this. Okay, that is the only conjugation possible here. Okay, now here is there any other conjugation possible? No, there is no conjugation with this negative charge because it is isolated position. See, in order to show conjugation how they should be positioned alternatively, like pi bond, sigma bond, again with pi bond, or with some positive charge, or with some negative charge, or with some radical. But here there is no pi bond with the alternate position with this negative charge, therefore no conjugation in A. So which means negative charge is least stabilized here. So in order to stabilize this negative charge, that should involve in the conjugation in the delocalization. So which is least stable? A is least stable. So A which is least in these two cases. Now why I am saying C is more stable than B? See, in B if you write properly, so what I told you, one type of conjugation is like this, okay, and is there any other conjugation? Check. Yeah, see, one thing is like this stabilization, yeah, this is fine, and if you observe properly, this double bonded oxygen not only involving in the conjugation with this negative charge, but it can also involve in conjugation with this pi electrons. It means the alkene double bond is participating with two different groups like one after the other. So this kind of conjugation we can say cross conjugation, which is less stabilizing factor because it is conjugation only, but when we compare with this, because this is a complete conjugation, this is partially, this double bond is involving partially, like see, this conjugation is taking place 50% with this and 50% with this. I mean there are two possibilities for this pi electrons to participate in conjugation with this and this, not in a continuous manner but in a cross manner. Therefore this conjugation is less stable than this C1, I mean in this, because it is a continuously conjugating, more number of resonating structures will be getting in this. So C is more stable than B and least is A. I hope it is clear. Okay. So I am trying with very basic way to teach to make you clear with the concepts. I hope it is helpful for you. Next. Same concept will you try to apply here? Just try to pause the video and give a try for this. See here, we need to stabilize these carbocations. Yes? Okay, which is most stable. Same story, whatever we discussed in the previous case, apply here. Okay. Now look here, this can be stabilized, this carbocation. Then if it is shifting here, we will be getting a positive charge here. This will be stabilized by this pi electrons. Therefore, we will be getting a carbocation here. That will be stabilized by this lone pairs like this. So it is a continuous conjugation, right? In this case also, when it is shifting here, we will be getting a positive charge here, and this pi electron will stabilize this positive charge. But more the number of resonating structures in 4, therefore 4 is more stable than 3. I hope it is clear. Next, let us go to this second application. Here, second option. So it will stabilize us like this, and we get a positive charge over here. So this positive charge will be stabilized by this pi electrons, right? Okay. Now look here. So this is just involving here, okay, but number of resonating structures are lesser than the fourth, so that's why I am writing 4 is most stable one again. So what about here? So this positive charge is stabilized by these pi electrons only, just one type, okay. So again I can say there is also cross conjugation in this, right? Okay, so this is also least stable, which is least, 1 is least, 4 is most. Okay, as a homework I want to ask you like number this question as a 1 #1, number the question as a #1, arrange this 1 2 3 4 based on their ability, like which is more stable, 4 3 2 1 something like that. You give the order of the stability in the comment box based on your understanding. If any help is required, I will discuss in the comment box. Okay, just try from your side to arrange them based on their stability order. So for this particular question, answer will be fourth one. What is my question here? Arrange the 4 options in their increasing order of stability. That is what my question. Yeah. So basicity they are asking, decreasing order of basicity of these amines. So always remember, aliphatic amines are more basic. So which is more basic? Third one will be more basic, because it is the lone pair electrons are freely sitting on this nitrogen, which are easily available to accept the H plus the proton. That is what the basic nature now. Ability to accept the H plus ion should be more. I mean proton is to be more. So for this basic nature will be more. It's clear up to here. Now here the lone pairs here involved in the conjugation. Here also involved in the conjugation. Again, these lone pairs will not be involving in the conjugation. So out of this, the least basic will be pyrrole. This name of this compound is pyrrole and it should be pyridine, and this is aniline. Okay. Now this is least basic I am saying, because due to the involvement of this lone pair of this pyrrole, it is getting aromatic nature. Therefore, they are very less available to donate or to accept the proton. Okay. Therefore, which is least? 4 is least. So, do we have any option? 3 is more, 3 is more, yeah, 3 is more, 4 is least. Yes. Then next here, these electrons are participating in conjugation. These electrons are participating in conjugation and these are freely sitting on the nitrogen atom. Therefore, this is more basic than this. So, 2, 3, 2, 1, 4 I am writing. So, do we have any option? 3, 2, 3, 2, 1, 4. So, fourth option is correct. I hope it is clear. Yeah. So, this is about the discussion and this is about the homework questions which I have given. So, I also discussed a session on aromatic nature now. So, identify. So, here I have for the last question itself, identify which of the following is aromatic. Okay, that is not only the question, I just want to mention here one more. So, identify the aromatic compounds from this. So, this is hashtag question number 2 as a homework for you. So, option 1 and 2. This is 3, 4. Just tell me number of aromatic compounds, like just indicate the number. Like first one, if one is aromatic, then give one aromatic, comma. If 2 is aromatic, give 2 also. If not, just leave it 1, and if any other is there, just write those numbers also. Yeah. So, out of these 6, identify number of species which are aromatic and tell me in the comment box. So, these are the homework questions for you as of this video. Okay. I hope this session will be highly helpful for you, and I hope your preparation is going well. So, if you have any difficulties in your preparation, so you can directly contact us to the provided mobile number and we will be discuss on that. Okay. So, thank you for watching. Happy learning.